Hello everyone. This video, let's see insertion sort algorithm. In this, I'm going to explain both the iterative as well as the recursive algorithms. In the iterative algorithm of insertion sort, we take a current element and we try to find the correct position in which the element should be inserted in a sorted order to maintain the sorted order of the array. So first we take the value to insert as a of I, which is the current element. We initialize the position equal to I, and while the position is greater than 0 or all the greater elements, that is array of position minus 1 is greater than value, we have to shift all the greater elements than the current element by one position to the right. So we are doing array of position equal to array of position minus 1, or we can also do array of position plus 1 is equal to array of position, but for that we'll have to change all our cases. And then we are doing position minus minus. So at the end of this while loop, we will get the correct position to insert a given value, that is array of I. And and in this way we can insert all the elements of the current array in the correct position, and hence we have sorted the array. Now let's see the recursive algorithm. But before that, let me tell you the time complexity and space complexity of this algorithm. Insertion sort in the iterative algorithm, we are doing n jobs, and basically we are traversing n elements in the loop. N I'm assuming is the length of the array, and in this while loop also we can traverse for a maximum of n times. So the time complexity becomes big O of n square, while the space complexity is big O of 1, as we are only using constant variables and not any array or vector which are depending on the size. So space complexity is big O of 1. Now let's see the recursive algorithm of insertion sort. First, I've taken the base case as if size or the number of elements is less than equal to 1. So one element is sorted as it is. So we can directly return from the function. And in the next step, I'm calling the recursion call. In this, I am calling my recursive insertion sort function for n minus 1 elements. So it will return me the array in which n minus 1 elements are sorted. And in the next steps of the function, I'm going to sort the last element of the array. Insertion sort the last element, which means I'm going to place the last element of the array at its correct position using all the n minus 1 sorted elements. So similar to the iterative insertion sort, I am going to use this while loop in which I'm going to move all the greater elements than the last element by one position to the right, and hence I'm going to create a position or a space to insert our last element, and at the end I'm going to insert the last element, and then I'm going to end the function. So here the time complexity is same as the iterative insertion sort, which is big O of n square, while the space complexity is big O of n. But why big O of n? Because in this we are calling the recursive function for n minus 1, rather n times, because at the end we'll check n is equal to 1 or not. So your n times, that is the length of the array, and hence as we know that recursion uses stack internally, so it is big O of n. Now let's see the code quickly for this algorithm, which is insertion sort, and I have implemented this in C programming language. So this is the code. I hope you will understand it as you have understood the algorithm or the pseudocode. So let's try to run this code. I'm going to open my terminal, and I'll type gcc, and my program name is q2.c to compile this program. And then you can see that an a.exe file is generated, a.exe, and I'm going to run a.exe. So if you are in Linux or Ubuntu system, then you may get an a.out file. So I'm going to run it as /a.exe. So first is asking me number of elements, so I've inserted 5. So I'm typing any random element for the array, 0, and let's say 5. So it is giving me the original array, and it is asking me to sort using iterative or recursive insertion and all the other algorithms, which I'm going to explain you in the next videos. So let's sort using iterative insertion sort, which is the third one. So the array is sorted. Similarly, we can also run for recursive insertion sort. Hope you have understood the video. If you have any doubts, do comment below. I'll try to answer it to the best of my knowledge. Thank you.